Hi guys, welcome to Edutainer. Now in this video, we'll learn about the light sensor and its working with the Raspberry Pi. So let's begin with the introduction. So we need a Raspberry Pi, that is the main component. We will be interfacing this Raspberry Pi with our photo sensor, and for this we need a breadboard to make the connections. A photo sensor, you can see this is a photo sensor with three pins: the signal pin, ground pin, and the middle one is the VCC pin of this photo sensor. And you will need an LED, this 220 ohm resistance, and these are few wires to make the connections. So let's begin with the connection. So just take the breadboard, place this LED. This is the positive pin, the longer one. Negative one is the shorter one, is the negative pin, sorry. So just place it on breadboard. So I have placed it. Just connect 220 ohm resistance. You need to bend it from the sides and connect it to the positive pin of this LED. And now just place this photo sensor here, over here. Yeah, it's done. And now I'm going to connect this setup to our Raspberry Pi using these jumper wires. So just connect it. So just give the 3.3 volt power supply to your photo sensor. So just use the pin number 1, is the pin number 1, and just give it to the middle pin, that's the VCC of this photo sensor. And now make it ground. Just connect the negative pin to the ground one. So for the ground purpose, I am using here the pin number 6. So it's the pin number 6, yeah, over here. And now connect the signal pin to GPIO pin number 7. So it's the pin number 7. Yeah, it's the pin number 7. Okay. Now our photo sensor is now connected with the Raspberry Pi, and now we'll connect the LED. So just connect the LED positive leg through 220 ohm resistor with the GPIO pin 8. So just connect it to pin number 8 here. Okay, now let's connect the another negative pin of this LED to the ground, and for this time I am using the ground pin number 9. So let me do this. Okay, so now it's done. Our setup is completed. Now let's move to the coding part. So okay, now I'm going to write the code for this photo sensor. Yes, so first as I am using the GPIO pins, so you need to import the GPIO library. So just import rpi dot GPIO, it will be in capital, as GPIO. So the library, the GPIO library is imported, and now this line will import actually. And now I will import the time library, import time, and now set the GPIO in the Raspberry Pi, set the Raspberry Pi in the board mode. So just use the GPIO dot set mode GPIO dot board. So the board mode has been set up here, and now as I have connected the photo register in the GPIO pin number 7, So we need to use it as an input, so we need to declare it the pin number 7 of the Raspberry Pi as an input. So just use GPIO dot setup, it's a setup, and inside the bracket we'll declare the pin number 7 as the input pin. So GPIO dot in. Okay, now let's as I have connected the LED on the pin number 8, so we need to declare the pin number 8 as a output, as we want to make it to turn this LED on and off. So we need to use pin number 8 as output. So you need to write this particular line for it, GPIO dot setup, GPIO dot setup, inside bracket declare pin number 8 as the output pin dot out. Now we'll set the warning. So just you need to if you don't want to do that, because the set warning, if I set the warning, you will not see any kind of unnecessary lines when I will run this code. So just leave it. Do not need of it to set the warnings, so just leave it. And now coming to the logic part, this we need to run this code repeatedly. So okay, now we need to create the loop, because we need to run this code repeatedly. So I'm just using the while loop. So just create a while loop. This will run infinite times, and just press enter, and you need to give the proper space to create like a braces for this while loop. So just press tab, it will give the proper space. Now declare, just create a variable x equals to GPIO dot input 7. This particular line reads the input by the photo sensor. So it basically, I'm storing this value to the x. The value of the photo sensor is going to be stored in the x, as I have written this line. So now let's create the logic tab. So we want to just as a photoresistor, if the intensity of the light falls on it, the resistance of photoresistor decreases. So in that case our LED will be low. So for that purpose we need to create a condition. So I am using the if statement. If statement will create a condition if x is equals to 0. So now you need to colon for the condition. Now press enter and then press tab, 2 times tab, because we need a proper alignment of this code, and this will be easier to understand if you use the proper space. So now GPIO dot output 8 comma GPIO dot low, because we have connected our LED to pin number 8, so we need to turn it off when the value of x is 0. So just how this line will work, this will turn off the LED. Now we want to turn it on again. So just tap, and now we'll create one more if statement to turn it on if the value of x is equals to 1. So you need to turn this LED on. So just use the statement GPIO dot output 8 comma GPIO. To turn it on, we need to do declare it as high. So GPIO dot high. So LED is turned on. Now our code is completed, and now we need to save it. Save this code. Just save it. Control S. And here I am saving inside the Pi folder. So just give the name photo sensor or light sensor simply .py. Okay, just save it. Now open your LX terminal to run this code. I'm going to run it. So just go to the system tools, then LX terminal, click on it, and just type here, just type python space file name. So as you have saved the file name as the photo sensor, so you need to call that name photo sensor, and don't forget to use extension .py. So photosensor.py, just press enter. Okay, now it's done. So guys, let's see the final part, that is your output. Now you will see. So yeah, up this time just observe this LED. Now I'm covering it, so you can see this LED is on. If I remove this cap, the LED is off. Again, this on, off, again on, and this is off. This is how this simple project is done, and it's very simple. You guys can do this very easily. So you can see the output. Okay, so thank you guys for this awesome project.